Safe. All right, we good. Let me start with, in fact, problem 32, you want to find the Laplace inverse of that function, and then step function or piecewise function needs to be defined. Okay, so consider this function. It's a function that is 0 for t less than 0, and if t is bigger than or equal to 0, it's 1, which simply has this graph. At 1, it's the horizontal line, constant, and then at 0 is that guy, or for less than 0. So this is t, and this is u of t. Hold on a second. So it says on your Cisco WebEx site, go to my WebEx preferences, personal room, automatic lock from modern view. To be honest, I have the app. Oh, you know what? Let me figure it out later. I don't want to waste time class for that. But thanks. So I'll check that later, and hopefully it works. But at the moment, it's unlocked. Okay. So I'm gonna call this u of t. Okay. So let's call that u of t, and then I can shift this function with any constant a. So if a is any constant number, u of t minus a basically is the same thing, except the input this time is t minus a. So if t minus a is less than 0, it's 0, and if t minus a is bigger than or equal to 0, is 1. Basically, this means if t is less than a, it's 0, and if t is bigger than or equal to a, it's 1. And they use a certain notation like u sub a of t. Okay, for example, and it has this graph this time. So if this is a, if it's bigger than or equal to a, it's 1, and for less than a, it's 0. Okay. Example, u sub 2 of t is 0 when t is less than 2, and if t bigger than or equal to 2, it's 1. Okay. And again, it has this graph. At 2, you have 1, and then 0, like that. And what we can do with this, we can find Laplace of that. So, what's the Laplace, for example? Let's find u sub a of t in general. Formula was 0 to infinity e to the negative st. U sub a of t dt. But this function is 0 at some values, right? And then 1 for values bigger than or equal to a. In fact, if you split this up from 0 to a, you can go ahead and assume a is bigger than 0. So it's 0 to a, e to the negative st, ua of t dt, plus a to infinity, e to the negative st, u sub a of t dt. Good, we have no lags. But, when t is less than a, which is this guy, ut is 0, so that entire integration is 0. And when t is bigger than a, that guy is 1, so you were dealing with a to infinity, e to the negative st dt. Simple as that. And we know how to do this one. We don't have to write down 0. So this is, let me write here. It's what? It's negative 1 over s e to the negative st, and then a to infinity. Remember, at infinity, that's 0. And at a, it's e to the negative at divided by s. So the Laplace of u sub a of t is equal to that guy, right? And that means, in terms of inverse, Laplace inverse of e to the negative a. I made a mistake here. That should be negative as. That's negative as. So that reason, that's also negative as. It has to be a function of s. This is simply u sub a of t. Okay. Example. In fact, let me do the problem in the book. 10.1, problem 32. In case someone has that question. So find the Laplace inverse of 2 s to the minus 1 e to the negative 3s. Okay. First of all, 2 is a constant. Pull that out. So it's Laplace inverse of e to the negative 3s, and then s to the negative 1. You can write it in the denominator as s. And you know what that one is, right? That's u sub 3 of t, according to this formula right here. And what does it mean? What function is that? If you graph it, that means the breakoff is at 3, and at 3 is 2, because it would be 1, the function itself, multiplied by 2, so the value starts at 2. So that's 2, and on the left side is just 0. Okay. Okay. Now, so that was, you can add this to the table of, you know, your Laplace formulas. You're welcome to make a table for yourself to just build up, like add rows of these formulas, just like the one in 10.1.2 table. And you can use this table for the quiz today. I'm mentioning that in the quiz. All right. Let's continue with, let me call it transitions. I think that's what 10.3 is called. Yeah, transitions. So transitions of Laplace. Let me begin with this. Consider the function. I mean, at some point I have to take derivative, so I'm going to start with this. Consider this function e to the negative st. Okay. Let's take derivative of this function with respect to s. So that means s is the variable you know, deriving this function with respect to. Will u of t always be that same piecewise function? Yes. I mean, in this case, called a step function. Okay. So we're going to derive this function with respect to s. So what's derivative? Well, it's going to be negative t e to the negative st. Correct? Should we write that as 2? It doesn't matter. It would be the same. So if someone wrote this as 2 u of t minus 3, they're both correct. Either one is fine. Okay. Okay. So everybody okay with that derivative? With respect to s. So with respect to s, t is a constant, right? It's like you're taking the derivative of e to the 5t. What's the derivative? Is 5e to the 5t, right? All right. What's the second derivative? Let's find the second derivative. So the second derivative of that, ds square of the same thing, it's basically the first derivative of the derivative that we already found. It's the first derivative of this derivative that we already found. Again, with respect to s, right? Well, it's going to be another negative t multiplied by that negative t e to the negative st. But you know, negative t is t squared. But I'm going to go ahead and write it this way. It's going to be negative 1 squared t squared e to the negative st. Right? For the same reason, let me write this guy as negative 1 to the first, t to the first, and then e to the negative st. Taking first derivative. It's very simple to calculate the third derivative with respect to s, e to the negative st, and you'll see simply it's negative 1 to the third, t cubed, e to the negative st. And in general, d sub n, or the nth derivative with respect to s of e to the negative st, equals negative 1 to the n, t to the n, e to the negative st. Okay? That's very simple algebra, and you can, you know, show it inductively. All right. Now, this is the first transition that I'm going to talk about. What's the Laplace of f of t? First of all, we named it f of s, and by the definition, this is 0 to infinity e to the negative st f of t dt, right? So with that definition, this guy is a function of what variable? What's the variable of that entire function? In fact, it's far left. You can see it. The variable of this function is s. It's right there. So it's a function of s. That means we can derive this with respect to s. Okay. So let me go ahead and take derivative. I want to just go ahead and take the nth derivative of this function. It's the nth derivative of this function with respect to s. So it's going to be basically the nth derivative of this integration, 0 to infinity e to the negative st f of t dt. Okay. Do you guys remember the definition of derivative in Calc 1? In general, f prime of x was the limit. In fact, that's it. It's the limit. You know, f of x plus h minus f of x divided by h approaching 0. So derivative is defined as limit. So this derivative is nothing but a limit. Do you guys remember definite integration? For example, integral from a to b f of x dx. That was also defined as the definite of some limit. It was the limit of b minus a divided by n, and it was the summation, you know, f of a plus k times b minus a divided by n, and k starting from 0 to n, 1 to n, sorry, and then n approaching infinity. But my point is that integration was also defined as limits. So for that reason, that's also a limit. So basically, we're doing the limit of another limit. And under assumption that these two exist, we can exchange these limits. We can switch them, right? So instead of doing derivative, then integration, instead of doing integration and then derivative, I can shove the derivative inside integration and do derivative of the integrand, okay? So let me erase this crap. Go away. So that's equal to, I can do 0 to infinity d n, oh, that should be dn, of, and remember this whole thing, since we're taking the derivative with respect to s, only e to the negative st has the variable s. Everything else is constant. So it's only derivative of that, and then f of t dt, okay? We already know what derivative of that one is. It was negative 1 to the n, t to the n, e to the negative st, and the rest of that's the same. Integration 0 to infinity. Pull out the constant part. The only constant part is negative to the n, negative 1 to the n, okay? 0 to infinity, e to the negative st, t to the n, f of t dt, okay? So remember, what did we start with? We started with nth derivative of f of s. And we ended up with this. Now, by the definition of Laplace, this piece is nothing but the Laplace of this chunk. So it's the Laplace of t to the n f of t. Okay? The rest the same. All right, here we go. Let's go ahead and multiply both sides by another negative 1 to the n. So multiply this one by negative 2 to n, 1 to the n, negative 1 to the n. When these two get multiplied, it's going to be negative 1 to the 2n. And negative 1 to the 2n is equal 1. because it's an even number. You multiply -1 by itself even times, right? So that's 1. For that reason, I can leave that line over there. Since -1 to the 2n is 1, we have, I'm going to write it this way. So I'm going to start with this side. This is the first transition formula. Equals -1 to the n, nth derivative of f of s. I don't think this formula is in that table, so you can add it to your list if necessary. Okay, and this works, by the way, this is true for any non-negative integer n. In fact, for n equals 0, it's just the normal Laplace formula that we already know. If n is 0, anything raised to 0 is 1, so we just get the trivial formula, Laplace of f of t. That's what we named it, right? F of s. A Laplace of t f of t is simply negative f prime of s. Laplace of t square f, that's f double prime of s, because -1 to the second is +1, and so on. Okay. Now, let's, for example, find the Laplace of t sine t. Okay. So we sort of applying this formula right here. And this plays the role of f of t. And it needs us to already know the Laplace of f of t, which is Laplace of sine t. What is Laplace of sine t? That's 1 over s squared plus 1, right? So in fact, this is our f of s. Now, according to Laplace of t f of t, this one right here is equal to negative derivative of the Laplace of f of t, which is f of s. So it's derivative of 1 over s squared plus 1. And we go ahead and derive that, right? So it's negative, s squared plus 1. It's 0 and then minus 2s, right? So finally it's 2s over, squared. So it's that guy right there. So Laplace of t sine t is 2s over s squared plus 1 squared. Okay. Or, Laplace, I'll just set it up and then you guys can finish it later. So t squared cosine t. So the formula says this is the second derivative of Laplace of cosine of t. Right? In fact, there would be -1 to the second, but that's 1. So it's going to be the second derivative. What Laplace of cosine t? It's s over s squared plus 1. Whatever that derivative is, second time, twice. Question on that? So that was the first transition formula. Should I explain any of those examples that we talked about? So if you go to problems 10.1, what's problem was it? So problem 21, problem 20, it can be done that way. Okay. All right. Now let me talk about this one. So yesterday we talked, not yesterday, it was Monday. We talked about Laplace of a derivative of a function, right? And ended up being s f of s. Well, let me write it in terms of Laplace. It was s times Laplace of f of t itself minus f of 0. Good? Now, I'm going to apply this. So let's say if I have a function, let's say g, and then Laplace of g prime of t equals s Laplace of g of t, right? Minus g of 0. Same thing. I'm just replacing f with capital G. But I'm going to apply this to a specific g. So consider function f. Let's change the variable to r. Integrate this function from 0 to t. Okay. So this guy, this integral at the end is a function of t. I'm going to go ahead and call it g of t. Good. For example, if you have, not that, I want to go consider, x squared dx, and then integrate this from 0 to t. So it's going to be x cubed over 3. And when you integrate this from 0 to t, you'll see it's going to be a function of t cubed over 3. So that's what I'm naming that as a function of t. All right, let me erase that. Now I have a question for you, and you should remember it from Calc 1. This function is a function of t, and I can derive it with respect to t, g prime of t. Anybody know what g prime of t is? From Calc 1? 9r? No, I'm talking about this specific g, this one right here. Like basically, what's the derivative of that integral? Eli, you're correct. You just have to remember it's a function of t, so it's going to be a small f of, not r, the variable of the function t. So this is f of t. Okay. And I have another question. What's g of 0? Simply, you're setting this t up there equals 0. That means you're doing integration from 0 to 0 f of r dr. Integration from 0 to 0 is 0. Okay. These are the two pieces we need. Now, so I'm going to apply this formula to this function g of t. Let's write it down. Okay, so it's Laplace. Derivative of g prime, it's f of t, equals s Laplace. G is the integration of, 0 to t f of r dr. That's my g of t term. Minus g of 0. And minus g of 0, g of 0 is 0. Okay, let's rewrite it. The left side, we have a name for it. What did we name it? We call it f of s. So equals s, and then Laplace, let's rewrite that guy. The integral of f. Now, if we solve for that, all we have to do is divide by s. So here's the integral formula, similar to the derivative, right? So the antiderivative of f, it's f of s divided by s. Let me write down the derivative and you can compare it. So the derivative one was s, f of s minus f of 0. So the top one is integral, the bottom one is derivative. Okay. So that's another one. Let's do an example. Let's see if we can find a non-trivial function. Let's see. Laplace of, so I want to go to an integration. It's going to be gamma of 0, huh? Let's see. I want to go with this. Natural log of t, okay? So the initial function, give me a second. So 1 over t, so it's t to the negative 1. That is going to be gamma. It's not significant. Let's do an obvious case. So let's do the integration from 0 to t e to the 2t dr. Okay, so this is our function, right? That's our f of r. And we know what the Laplace of that is, right? So we know Laplace of f of t, which is e Laplace of, e to the 2t, that's 1 over s minus 2, okay? Now Laplace of this integral is simply f of s divided by s, which is going to be 1 over s times s minus 2. Okay. This one is used like less frequently than derivative. Like derivative is used like a lot, especially in solving differential equations. I mean, it's called differential, so you're dealing with derivatives, whereas you're dealing with integrals. Unless there's a specific, function that is given its form of integration, and then you apply Laplace to it. Okay, question so far? I'm going to go to the next transition. So let's do a very quick summarizer. So we did Laplace of u to the t minus a. That one ended up being e to the negative as divided by s, okay? We did Laplace of t to the n, f of t. That was negative 1 to the n, nth derivative of f. And we also talked about Laplace of integration 0 to t, f of r dr. That ended up being f of s divided by s. And remember, in all of them, f of s is just the Laplace of original function f of t. All right. Now I'm going to talk about the next transition, and that's consider a function f of t and multiplied by e to the at. This one is going to be used a lot, especially when we start 10.3. Okay, so basically you have function f of t multiplied by e to the at. Let's write down definition. 0 to infinity, e to the negative st. This entire function goes here, e to the at, f of t dt. Okay, so it becomes 0 to infinity. I'm going to put these two together. It's becoming e to the negative s minus a t, f of t dt. Okay. Question on that, putting these two together. In fact, if you distribute the negative, split them up, we get the same thing. Negative times negative is positive a. So now, let me write something here, and then we're going to figure out what this is in terms of the original Laplace. If f of s is 0 to infinity e to the negative st, f of t dt, question for you. You can open your mic and say what I have to do. What is f of 5? Can you slow down a tiny bit, please? Sorry, thank you. I will, definitely. Okay. So that's the entire screen. So down here, my f of s is that Laplace definition. Question for you. What is f of 5? what should I do on the right side? What should I replace what with what on the right side? You put 5 in for s, that's it. So you do 0 to infinity e to the negative 5t f of t dt, okay? How about this one? What is f of s minus 7? Do I do the same thing? Simply I replace s with s minus 7? Say yes or no. So do I replace s in this guy with s minus 7? Is that what I do? Yes or no? The answer is yes. I mean, think about it. What did we do from here? We simply replaced s with 5. Well, we do the same thing. Wherever we see s, we replace that with s minus 7. So it's going to be e to the negative s minus 7 times t f of t dt. Okay? Now, that being said, so think about it. I mean, look at this formula. E to the negative, when this is like the coefficient of t, if it's negative s minus 7, then this is nothing but, the initial Laplace evaluated at s minus 7. Now I'm going to go back up to that integral. This is equal to f of, you guys tell me what the input should be. S minus a, beautiful. So that's the transition I was talking about. Okay. So that tells us, I'll do an example simultaneously. Consider Laplace of, let's do cosine of t. Let's do sine of t, it's better. Sine of t. What's Laplace of sine of t? It's 1 over s squared plus 1. Okay? Now, I'm going to multiply sine of t by e to the 2t, and then take Laplace of that. This transition formula we got up there tells us, if you already know Laplace of f of t, which is capital F of s, if you multiply f of t by e to the at, Laplace of that is basically the same Laplace function you already had. Just replace s with s minus a, and a is that number in the exponent of e multiplied by t. So now you guys tell me, what is that? Laplace is going to be 1 over. What do I replace with what? With what? I replace s with. I replace s with. So what do I put in there? Is it 2 or s minus 2? S minus 2. Think about it. This one says replace s with s minus a. And you can FOIL this and simplify it. So, at the end it's going to be s squared minus 4s plus 5. So that's Laplace of e to the 2t sine of t. Oh, we'll do more example of that, okay? So that was the 4th formula we learned today for the Laplace, function. Okay, so let's begin with this. What is Laplace of e to the 3t times t? In fact, you can do this 2 different ways, and I'll tell you both ways. Oh, it won't confuse you. Okay, let's do it this way first. So if you do it this way, that means that's my f of t. So first think about Laplace of a t. What is Laplace of t? 1 over s squared. So we know Laplace of t is 1 over s squared. Now, since t is being multiplied by e to the 3t, I replace this s with s minus 3. Yep. Now, let's do it the other way. So this time I want to start with t and then multiply it by e to the 3t. It's the same thing, right? I'm just changing the order of multiplication. You remember this formula? Laplace of t, f of t. That was negative derivative of f of s, where f of s was the Laplace of that guy. And for us, this time f of t is that. Okay, so let's see. What is Laplace of e to the 3t? That's 1 over s minus 3. So in this setup, this is my f of s. Okay. Now, according to the Laplace of t times f of t, I have to derive it first. So let me derive it once. In fact, I do it here. It's the derivative of 1 over s minus 3, and I have to multiply by negative. You do that, and you'll see exactly, you get the same thing. It's 1 over, let me erase this guy, s minus 3 squared. So that guy can be found both ways. Okay. Let's do this one. This is number 1 in 10.3. Let's find the Laplace of e to the pi t, t to the 4th. Again, that one can be found both formulas, right? In fact, both ways that we just explained. But one is easier than the other one. Just like the one we explained above, like that one was easier to find, whereas you have to take derivative. If this was t squared, you would have to derive it twice, basically. So we're gonna give that guy the role of f of t here. So what is Laplace of t to the 4th? It's 4 factorial, which is 24, divided by s to 4 plus 1, which is 5, s to the 5th. Okay? Now, I write that down. Wherever I see s, since it's being multiplied by e to the pi t, I replace s with s minus pi. So that goes like that. Okay. Let's do one more. Laplace of e to the 3t cosine of 5t. Okay. Find Laplace of that first. So that's your f of t. Laplace of cosine of 5t equals to s over s squared plus that argument 5 squared, 25. Now go back up. Wherever you see s, you replace s with s minus 3. Let's make that a negative. So if I make that negative, I replace s with what? S minus 3 or plus 3? Plus 3. So that makes it s plus 3 and s plus 3. And you can simplify. So it's s plus 3 over, what is that guy? That's s squared plus 6s. 9 plus 25, it's what? 34? Okay. All right. The rest of 10.3 is mostly, let me see, is there any other transition that I need to talk about? No. I mean, there's more, but we don't need to talk about them at the moment. The rest of 10.3 is mostly partial fractions, okay? Let me do one, and it's going to basically help you for the quiz as well. I mean, these are crazy ones, but on the quiz, you're going to get easier ones. So problem 11 up to 22 says, use partial fractions, find inverse Laplace transforms of the given functions. Let me do... Let's do this one. I'm going to do number 19. Can one of s plus 3 cancel? No. Yeah, he's answering because, it's in the form of a addition. It's like you cancel x over x squared plus 5. Like, can you cancel x and x plus 5 and get at 1 over x plus 5? The answer is no. Unless it was a multiplication. Okay. All right. So number 19, do you need to find the Laplace inverse of s squared minus 2s over s to the 4th plus 5s squared plus 4. Okay? Let me double check. Yep, it's the one. Okay. So of course, that's a crazy function to write down Laplace inverse for. And denominator is a polynomial of degree 4. If you can recall in partial fractions, any polynomial of degree of 3 or higher is factorable or is reducible. It can be reduced to factors of degrees 2, which should be irreducible. If not, it should be all, factors of degree 1, linear factors. In fact, we already discussed this in when we were, factoring characteristic equations in solving differential equations. So you should be able, worst case scenario, you should be able to factor this to polynomials of degree 2 and 2. Okay. So let's see. We have s to the 4th 5s squared plus 4. Can we factor this maybe to 2 polynomials of degree 2? Do you think we can? Yes or no? And if yes, let me know what the factors are. Oh, it's quick. S squared plus 1, s squared plus 4. Right? Okay. So that's Laplace inverse of s squared minus 2s, s squared plus 1. I did double parenthesis. S squared plus 4. Can these be factored further? Or are they irreducible, basically? By the way, in real numbers, when you talk about complex number, of course, like s squared plus 1 was s minus I times s plus I. So here we don't do that. We only talk about real number factorization. The answer is no. You can't. Okay. Now, we have the ratio or, rational function like that. All right. I'm going to ask you guys, how many fractions can this rational function be decomposed to? 2. Exactly, that's 2. So denominator of the first one, or one of them, is s squared plus 1. What kind of functions do I write here and here? Do I do a constant or do I do a linear? Linear. Why? Because denominator is an irreducible second degree. So it's going to be as plus b and then cs plus d. Yes, it's correct, Jack. As plus b and cs plus d. Okay. You need to make sure you're including the constant term b and d. You have to account for that. Okay. Now let's find constants a, b, c, and d for which this entire equation holds. Okay. Find the common denominator, multiply both sides by the common denominator, and then collect like terms and then set the coefficients on either side equal to each other. So if you multiply both sides by the common denominator, which is basically that guy, on the left side, we only left with s squared minus 2s. Basically, the entire denominator cancels out. If you multiply by this guy, the s squared plus 1 goes away. So you're left with as plus b times the other term, s squared plus 4. Plus cs plus d, this time multiplied by s squared plus 1. Does anybody have question on that part? Like how we got from this line to this line? Again, we multiply both sides basically by the common denominator, s squared plus 1 times s squared plus 4. If you multiply by this guy, that's the same, expression in denominator. That goes away entirely. If you distribute it, you multiply by that one, only s squared plus 1 goes away. So you still have to multiply as plus b by s squared plus 4 for the first term. And if you multiply by the second one, similarly, s squared plus 4 goes away. You have to multiply that by s squared plus 1. Distribute. So we get a s to the third plus, what else do we have? bs squared plus 4as plus 4b. Okay, now we have cs cubed plus ds squared plus cs plus d. On the left side, I have the same thing. Let's combine like terms. So I have cube terms, that one and that one. So we get a plus c as the coefficient of s cubed. Simply factor out s cubed out of those two. Those are my square terms, which is b plus d s squared. Now s terms, I have that one and I have that one. It's 4a plus cs. And as you can see, the constant terms are 4b and d. Okay? And on this side, I have s squared minus 2s. Now, let's match up the coefficients. What's the coefficient of s cubed on the left side? 0. So for that reason, the coefficient of s cubed on the right side has to be 0. Coefficient of s squared is 1. So b plus d must be 1. Coefficient of s is negative 2. So 4a plus c is negative 2. And 4b plus d should be 0 because there's no constant on the left side. Okay. Now out of this system, it's just a system of 4 unknowns and 4 equations. Do whatever you need to solve for a, b, c, and d. Okay. For example, on this one, c is negative a. Now replace it in that one. So you have 4a minus a equals negative 2. That means 3a is negative 2, or a is negative 2/3. That means c is 2/3. Same thing. Out of this one, d is negative 4b. Okay. From that one, b minus 4b is 1. Negative 3b is 1. b is negative 1/3. I'll plug it in there. d is 4/3.
The line after 4a plus c equals negative 2.
Thank you. Oh, why is it negative 2? Or you're saying
No, it's 4a minus a is then equals minus 2?
Yes, because from the first equation, I got c equals negative a, right?
Mm-hmm.
And then I replace negative a for c.
Ah, gotcha.
So I get 4a minus a still equals negative 2. Okay. If I have an error or mistake, guys, please stop me. Open your mic, let me know. Okay. So this is what we ended up with. Laplace inverse, by the way, this is Laplace inverse, s squared minus 2s over that whole, what was it, s squared plus 1, s squared plus 4, ended up being Laplace inverse. Okay. So we had as. So as, it's negative 2/3 s plus b. b is negative 1/3. over s squared plus 1 plus now cs. cs is 2/3 s plus d 4/3 divided by s squared plus 4. Okay. Now I can break this down to 4 fractions. Okay. So it's Laplace inverse of negative 2/3 s over s squared plus 1 plus negative 1/3 over s squared plus 1. Let me write down all details. 2/3 s over s squared plus 4, 4/3 over s squared plus 4. You can pull out the constants. So first one is Laplace inverse. Oops, I am saying pull out the constants and I don't. So that's equal negative 2/3 Laplace inverse of s over s squared plus 1. Negative 1/3 Laplace inverse of 1 over s squared plus 1 plus 2/3 Laplace inverse of s over s squared plus 4. Plus, I'm going to break down that 4/3 to 2/3 and 2, okay? So I'm going to put the 2/3 outside. Laplace inverse of 2 over s squared plus 4. And you can see why. Okay. What's the first one? So it's negative 2/3. First one is the Laplace of cosine t. Next one, sine t. The one after that is cosine of 2t. And the last one is 2/3 sine of 2t. Okay. Question on that? So we can stop right here. Oh, let's do a 4 minutes break. It's 4:56. You guys can ask questions. No, we can do 1 or 2 problems, even 3 if we have time. No, you guys can go take the quiz. Sounds good? Okay, let's do it. Okay, no more questions? Any other questions? Since almost everybody, 34 people are here, write everything in just one single, scan everything into one single file. In fact, you can only submit one at a time, okay? So if there are, for example, 4 questions, do not, for the name of the file, do first and last name. There are 2 pairs that have the same first name but different last names. That's a little bit confusing. I should have mentioned that initially. And here's the important part. Only answer what the question is asking. Do not write extra stuff. I'll mark you down for it. So only read the question and answer what the question is asking. Okay? If it says there's something specific that you don't have to do it, then do not do it. Okay. Anything else? I can, dismiss you so you can get ready for the quiz in the next 5 minutes. Good? All right, guys. Good luck. Just release at 5:20. Answer 30 minutes, and then make sure you have time for submitting right after that. Yeah, it opens at 5:20. Okie doke. You guys take care.